of analytical geometry. So in analytical geometry, first of all, we need to remember all the formulas, right? From grade 9 and 10. What is the first one from grade 9? Gradient. Gradient small m is equals to y2 minus y1 divided by x2 minus x1. Right? Then the midpoint formula. What is it? X1 plus x2 divided by 2 and y1 plus y2 divided by 2. Then the distance formula. What's the distance formula? Square root of y2 minus y1 squared plus x2 minus x1 squared. Then finding the equation of straight line. So y equals to mx plus c, or to get that y equals to mx plus c, this is the formula we are going to use. Y minus y1 equals to mx minus x1. And to find a point of equation of a line, I need a point x1, y1, and I need a gradient of that line. That's all. If I don't have that gradient, I must find somehow the gradient. Okay. Then something related to parallel line. What is it? Something related to parallel line. M1 equals to M2. Two gradients are equal. Parallel line gradients are equal. Then the perpendicular line, multiplication of their gradient should be minus 1. Only those are the formulas you have, right? Related to a general calculation. And now in grade 11, there's one more formula. That's the gradient. And what is its relationship with tan theta? Theta. So m equals to tan theta, or if I'm looking for angle, then it is tan inverse of that gradient. Okay. So if I have this formula, and if I use it proper, I'm going to get most of the marks. Okay. So let's see what kind of questions they ask. In this diagram below, the line PS. So I must check where is that PS. Okay, there is that PS. Okay. Is defined by 3y plus 2x equals to 6. Okay, I don't want any equation like this one. I'll convert it into in the y form. 3y plus 2x equals to 6. So first 2x, we'll take it the other side. So I'll write negative 2x first plus 6 as it is. And then I will say 3y. Okay, I need y equals to. So I will divide by 3 both everywhere. So what I am getting? Y equals to negative 2/3 x. So it is mx plus 2. So for that line, I got the gradient and I got the y-intercept. Gradient and y-intercept. So I observe there now. Then I can write a gradient. M equals to negative 2/3 and my y-intercept should be 2. Okay, whatever I calculate on a side, right, I fill up my diagram with. Right. So that information is given. I will not go ahead until I finish my work on that point, at that point. Okay. And cuts the x-axis at. Okay. So this, it is cutting the x-axis at. Okay. They are telling me the point Q. Okay. 3 and 0. X-intercept. Okay. MQR. Okay. That's another straight line. MQR. Meets PR at 10 and 4. So the at R, the coordinates of R is 10 and 4. N is 6 and minus 2, point on PS, and PQR is theta. So that's the angle theta. Okay, remember that angle, whenever we deal with, we must observe where it is. Is that theta with x-axis? This is x-axis. Is that theta with x-axis? No. So I will not get direct answer using the formula. All right, be careful there. If that theta is with x-axis, if I say, if let's say if I put that theta here, now it is with x-axis. All right. So I can get the answer direct if I have a gradient of this line. M equals to tan theta or theta equals to tan inverse m. Okay. But in this case, keep it in mind what you have there. All right. Okay. So we have worked a little bit and we have more information now on a diagram. Let's see. All right. 1.1, determine the gradient of PS. Where's PS? Okay, the equation which we have. All right. So what the work what we have done is already giving me the gradient. All right. So it is 1.1. We have already the answer. My gradient is negative 2 over 3. We have answered already. Right? Now, the moment you get the first answer, you put it on your diagram, which I placed it somewhere. Right? Don't leave it in writing only. Right? Put it in your diagram as well. Then 1.2, calculate the inclination angle of MR. Okay, inclination angle of MR. This is the MR. Where is that inclination angle? Tell me. I'm reading it again. Calculate the inclination angle of R. We are not talking about theta. All right. And inclination angle, it is with x-axis. All right. So I can make it alpha because the word they use already theta. So I can't use again theta. All right. So I'm looking for alpha. Right. And that alpha is with x-axis. Isn't it? So if I'm looking for alpha, tan inverse of that gradient. Okay, what is that line? MR. Do we have a gradient of MR? Hmm? We don't have a gradient of MR. So I will first calculate the gradient. Okay. So what is that gradient? Small m of MR, y2 minus y1, x2 minus x1. Right? What did I tell you? Before you calculate anything, you write down those 2 points side by side. So it will be easy for you to subtract. Okay. So on that line MR, I don't have point M, but I have point Q. So what is that? 3 and 0, and R is 10 and 4. So it's easy for me now to substitute y2 minus y1, one line. Okay. So it is going to be what? 0 minus 4 over x2 minus x1, again straight line. 3 minus 10. How much it is? Negative 4 divided by negative 7, it's 4 over 7. Okay, that 4 over 7, now I'll substitute here. So it's 10 inverse 4 over 7. Right. We use a calculator. What's my answer? Alpha equals to, give me the answer. 29.74. Okay, so I'll add that 29.74. Okay. All right, so we're done with that one, 29.74. So that means whatever work I had done in the previous question, this next question, it might be useful in the next one. All right, so 1.3. What are we looking for? 1.3 theta. All right. So this theta, 1.3, it is not with x-axis. It is not with x-axis. So I will not be able to calculate direct answer using one formula. Right? So to get x-axis, I'm checking now. To get that angle, I'm checking now what I have so far. So far, I have x-axis. I have one angle, 29.74 alpha. I have theta. And there is one more angle which can complete the straight line. Isn't it? And straight line, I know 180. So if I can give this one a name beta and find out the angle beta, because the gradient of that line I know. Right? What is that gradient? Minus 2/3. Okay. I know that gradient, so I'll be able to get the angle. Right? So what is the angle beta then? Before I go for theta, I will calculate beta. Right? So tan inverse of that gradient, what was that gradient? Negative 2/3. What's my answer? All right. So when I'm getting a negative angle, what does it mean? Okay, this is my x-axis. This is the line. When I'm getting the negative angle, that angle's position is to the left hand side of the line and the x-axis. So it means this is 33.69. Okay, so negative answer is give you the angle between the x-axis and that straight line to the left hand side. So this is the left hand side. Negative answer means. Okay, so this is the position of 33.69. Then there is another line which we calculated. What was that other angle? 29.74. And this is theta. So now I can see three angles on a straight line. So how do we calculate theta? Therefore, theta equals to 180 minus 29.74 minus 33.69. Okay, use your calculator, give me the answer. How much? 116.57. It looks like obtuse angle. And we got the answer obtuse angle. How much it is? 116.57. 5657. Okay, doesn't matter. 57. All right. Any questions so far? Good. What do I need to prove now? Rn perpendicular to PS. What do we know related to perpendicular? When we started, this is the condition for perpendicular. So two gradient must be equals to minus 1. Okay. So which two lines they are talking about? Rn. So I'll mark. Okay. Rn. I don't have a gradient yet. And PS. Okay. That gradient I have. All right. So I need to prove this one is 90 degree. All right. So I will calculate the gradient of Rn. Small m Rn is this gradient. Okay. So formula is y2 minus y1, that's R, that's n, 10 and 4, and n is 6 and minus 2. Right. So y2 minus y1, straight line, 4 minus minus 2. So it's 4 minus minus 2. Divide by 10 minus 6. So numerator is 6, denominator is 4. 6 over 4, 3 over 2. Right. So m of Rn is 3 over 2 and m of PS I got negative 2 over 3, isn't it? So let me multiply and check what answer I'm getting. So m of Rn times m of PS gradients 3 over 2 times negative 2 over 3. What's my answer? The moment you get a minus 1, the gradient multiplication, then for I can say Rn perpendicular to PS. Okay. So now the moment there is a perpendicular, I am having a right angle triangle now. Keep it in mind. Right? So I'm trying to work for the next question. I don't know yet what is my next question. At the moment there is 90-degree, it's a right angle triangle. Maybe use of Pythagoras, maybe the area formula, half base times height, right? Maybe SOHCAHTOA, right angle triangle. Right? So those are the three things I need to keep it in mind. Okay. Let's see what is the question. Okay, you see now there is a area. What's the area of a triangle? That RQN. Let me check first of all. Okay, RQN. Okay, so it is they are not talking about that big triangle. Now we are talking about the small triangle. RQN. Right? So I'm looking for this area. And it is now right angle triangle, isn't it? So I can use, what is the formula for area of a triangle? Right angle triangle? Half base times height. Okay. So it is half base times the perpendicular height. Keep it in mind. Okay. So now I need to get base and perpendicular height. So those are the two lengths. All right. Okay. Do I have a length? That's n. Okay, n is given there. Right. So do I have qn? Distance qn. Qn, this distance. Distance. You calculated how much? So distance formula, square root of y2 minus y1 squared plus x2 minus x1 squared. So 0 minus minus 2 squared, that's y2 minus y1 squared, 3 minus 6 squared. What's the calculator answer? Loudly. Root 13. Okay. And this distance, what is that distance? Okay. So it's a square root 4 minus minus 2 squared plus 10 minus 6 squared. What's the calculator answer? Root 52. So I got two distances. Right? No need to simplify them. I'll put that distances straight away into that formula and I'll get the mark. So half is as it is. My base is root 13. Right. And root 52. I will use a calculator, get my answer. What's the answer? 13. Set. So 13 unit squared. Right. 6 mark, lot of marks there. Okay. All right. Right. So calculate the y-intercept of MR. So I need to find out the equation first. All right. And then mx plus c, that c will be my y-intercept. MR. It's MR. Okay, that's MR. And y-intercept I'm looking is there. All right. Okay. So how do we calculate equation of a straight line? Y equals to mx plus c. That is what I need to get. All right. And to get there, I will use y minus y1 equals to mx minus x1. So on MR, I'm looking for 1 point. Right? And on MR, one easiest point is Q because one of the values is 0. Right? So I will substitute at that point Q 3 and 0 and the gradient we have it for that MR. How much is it? What is the gradient of that line? M we calculated 4 minus 0, 10 minus 3. Okay, let me calculate. 4 minus 0, 10 minus 3. How much it is? 4 over 7, isn't it? Okay. So my gradient is 4 over 7. So the moment I substitute this two and simplify it, I'll get the answer. Right? Okay. So this one is x1, y1. So it's a y minus 0 equals to m minus x1. x1 is 3. Right? So 4 over 7x minus 4 over 7 times 3 multiplication. So 4 times 3, 12 over 7. That's y. Okay. So this is my y-intercept. Negative 12 over 7. So y-intercept is negative 12 over 7. Right? So it's negative value. So does it cut below x-axis? Yes. Okay. So I will accept it. So I'm going on a right track. All right. Any question? No. All right.